Hello students, let's try to understand occurrence of metal, okay, and their extraction we are going to study for the class 10th NCERT book. So dear student, the earth crust is the major source of metal. Seawater also contains some soluble salt such as sodium chloride, magnesium chloride, etc. The element or compound which occurs naturally in earth crust are known as minerals. At some places, mineral contain a very high percentage of particular metal, and the metal can be profitably extracted from it. These minerals are called ore. These minerals are called ore. Now go for the extraction of metal. You have learned about the reactivity series of metals. Having this knowledge, you can easily understand how a metal is extracted from its ore. Some metal are found in the earth crust in the free state. Some are found in the form of their compounds. The metals at the bottom of the activity series are the least reactive. The metals at the bottom of reactivity series are the least reactive. They are often found in free state. They are often found in free state. For example, gold, silver, platinum, copper are found in the free state. Copper and silver are also found in the combined state as they are sulfide or oxide ores. The metal at the top of the reactivity series like potassium, sodium, calcium, magnesium, aluminum are so reactive that they are never found in the nature as a free state. The metals in the middle of the activity series like zinc, iron, Pb, etc. are moderately reactive. They are found in the earth crust mainly as oxide, sulfide, carbonates. You will find that the ore of many metals are oxide. This is because oxygen is very reactive element and is very abundant on the earth. Thus, on the basis of reactivity, we can group the metal into the following three categories. Now, see the figure 3.9 we are going to explain here. Where is the 3.9? This one, three categories are there. So the highly reactive metals are extracted by electrolysis method. In middle one is the moderate reactive metal by reduction using carbon, and that is least reactive found in the native state, means free state. Now see, metals of the low reactivity series, metals of medium, metals of the high reactive. Different techniques are to be used to obtain the metals falling in these categories. Several steps are involved in the extraction of pure metal from ores. Summary of these steps in given in figure 3.10. Each step is explained in detail for the following section. So first of all, ore, from where the extraction of the metal takes place economically. So the first step is concentration. Second one, that is metal of high reactivity undergoes electrolysis and pure metal. Metal of medium reactivity, carbonate ore, sulfide ore, calcination, roasting. So oxide it will convert into oxide. So reduction of metal, purification of metal, and then pure metal. Metal of low reactivity, sulfide ores are roasted metals and refining. So they are the steps. Okay. So enrichment of the ore, that is concentration of ore. Enrichment of ore means concentration of ore. Ore mines from the earth are usually contaminated with the large amount of impurities such as soil, sand, etc. called the gangue. The impurities must be removed from the ore prior to the extraction of the metal. The process used for removing the gangue from the ore are based on the differences between the physical or the chemical properties of the gangue and the ore. Different separation technique are accordingly is employed. Extracting metals low in reactivity series. Metals low in reactivity series are very unreactive. The oxide of these metals can be reduced to metal by heating alone. For example, Cinnabar HGS is an ore of mercury. When it is heated in air, it first converted into the mercuric oxide HgO. Mercuric oxide is then reduced to mercury on the further heating. So HGS plus 3O2. So HgO means Hg plus O2. Similarly, copper, which is found in Cu2s in nature, can be obtained from its ore by just heating. Cu2s is converting into Cu2O, Cu2O is converting into Cu. Okay, extracting metal in the middle of the activity series. The metal in the middle of the activity series such as iron, zinc, lead, copper are moderately reactive. These are usually present as sulfide or carbonates in nature. It is easier to obtain metal from its oxide as compared to its sulfide and carbonate. Therefore, prior to reduction, the metal sulfide and carbonate must be converted into metal oxide. The sulfide ores are converted into oxide by heating strongly in the presence of excess air. This process is known as roasting. The carbonate ores are changed into oxide by heating strongly in limited air. This process is known as calcination. The chemical reaction that takes place during roasting and calcination of zinc ore can be shown as follow. So roasting, so ZnS3O2, so it is converting into zinc oxide. Calcination, ZnCO3 converting into zinc oxide, but one in the oxygen means the roasting, and there is no oxygen means calcination. The metal oxide are then reduced to the corresponding metal by using suitable reducing agents such as carbon. For example, when zinc oxide is heated with carbon, it reduced to metallic zinc. So ZnO plus C is equal to Zn plus Co. You are already familiar with the process of oxidation and reduction explained in the first chapter. Obtaining metal from their corresponding is also reduction process. Besides using carbon coke to reduce metal oxide to metals, sometime displacement reaction can also be used. The highly reactive metals such as sodium, calcium, aluminum, etc. are used as a reducing agent because they can displace metal of low reactivity from their compound. For example, when the manganese dioxide is heated with the aluminum powder, following reaction takes place. 3MnO2 plus 4As, MnAl2O3 plus heat. Can you identify the substance that getting oxidized and reduced? These displacement reactions are highly exothermic. The amount of heat evolved is so large that the metal are produced in the molten state. In fact, the reaction of iron third oxide with aluminum is used to join railway track or the cracked machine parts. This reaction is known as thermite reaction. Fe2O3 plus 2Al, it is going 2Fe plus Al2O3. Extracting metals towards the top of the reactivity series. The metals high up in the reactivity series are very reactive. They cannot be obtained from their compound by heating with the carbon. For example, carbon cannot reduce to oxide of the sodium, magnesium, calcium, aluminum, etc. Hello. To the reactivity series. This is because these metals have more affinity for oxygen than the carbon. These metals are obtained by electrolytic reduction. For example, sodium, magnesium, cesium are obtained by electrolysis of their molten chlorides. The metal are deposited at the cathode, the negatively charged electrode, whereas the chlorine is liberated at anode, the positively charged electrode. The reactions are: at cathode, Na plus electron, sodium; at anode, 2Cl minus Cl2 plus. Similarly, aluminum is obtained by electrolytic reduction of aluminum oxide. Now we are going to study the refining of metal in the next video. So this is all.